Hello, congratulations. We have done the calculus in this grade 12 calculus and vectors course, and we are going to start vectors. So what is a vector? Vector is just a value that we use to describe a quantity. So before we have used the scalars for temperature, for area, for speed, for mass, for age, we use one number. Then we could describe that stuff. And for some quantities, we need to have two things to describe. For the weight is gravitational force is down, and for velocity we have the directions east, west, or other front, forward or backward, or fractions. Fraction we could have the left side, right side, and we need two numbers to describe that quantity. Then that we call a vector. So they have two things for that quantity. So one is magnitude, how the numerical value for that quantity, and also you need a direction. So these two things describe one quantity. And the example is weight, velocity, friction, or other numbers. So the direction we use arrowhead. So arrowhead describes the direction, and the length we call it the magnitude. So now we are going to see some special vectors, opposite vectors. Opposite vectors means you have the same magnitude. The length of the vectors are equal but opposite direction. We call this opposite vectors. Equal vectors, it means you have the same length, same magnitude, and also same direction. So we call it equal. This is equal vectors. This is opposite. The direction opposite, but the magnitude same. Parallel is just they are parallel, and this could be, so these two parallel, and also you could have the opposite direction. As long as they are parallel, we call it parallel vectors. So now we are going to practice. Example 1. We have these figures here. It asks you to find another vector in this rhombus equal to AB. So from A to B direction is this one. Equal one will be this one. Same magnitude and also same direction. So for the A, it's from D to C, and we've put arrows above it. And for the B, DA, from D to A is from C to B. Same magnitude and same direction. CEB, EB is from here to here. So same magnitude, same direction is D to E. And the question D, A, from A to E and E to C, they are same magnitude and the same direction. So in order to have the two vectors equal, you need to have two conditions: magnitude equal and also direction same. Then continue. The definition for the direction between the two vectors is the angle formed when the vectors are placed tail to tail. So for example, if we want to find the angles between the DA and DC, we need to tail together. then this angle less than 180. So this side will be greater than 180. Another angle must be less than 180. Then this angle, we call it angle between the two vectors. So the whole circle is 360. So whole circle is 360. Any angles formed between the two lines, it must have one angle is less than 180, another one greater than 180. So there are several laws we could use for adding, subtracting, multiplying a scalar number to the vectors. So to find the sum of two vectors, we could use a triangular law of vector addition. So we just draw the triangle. So from U, this is U, then the height to another one's tail. Then U plus V will be this from height to the tail. The height of the first vector to the tail of the last vector. Even if you have more vectors, you can continue. Vector 1, vector 2, vector 3, vector 4. The sum of all this one, you just put tail height, tail height, tail height, tail height. So height and tail together, then the first tail to the last height is the sum. So this is the adding of vectors. So if you graph it, and A plus B, the order doesn't matter. So V, then you plus another U here, it will give you the same. So the order doesn't matter. And A plus B plus C, you change the order, it's okay. Scalar times, you can times it first. So each of them you could double, then do it together, or you find the final one and double it. It's same. So times a constant, you can times it first, then add, or add first times. So if it's at a zero vector, then nothing change. It will be A. And if you have times a scalar only, you just times a scalar together, then times a vector. So you add two scalars bracket, you can separate it, MA plus NA. So these are several laws you could use. Then after that, we are going to see more examples. So this one, find the magnitude and the direction of the sum of two vectors U and V. If their magnitude is 5 and 8 units, and the angle between them is 30 degrees. So for such vectors given, there's no xy coordinate. We call them geometric vectors. There's no coordinate xy axis there. And later we are going to see if we put them in the xy coordinate system, it will be easier. And if we put those in the xy coordinate system, we call those vectors as algebraic vectors. So we are going to show you both methods to find the resultant vectors. So 5, 8, and 30 degrees. So we could just draw it. So U, we just draw it randomly. So U is 5 and V is 8. The angle between these two is 30 degrees. We have learned that in order to add those two vectors together, we have to, this is a tail, this is height, then this one we need to move it here. tail to height. So we need to move this way here. They are equivalent vectors, so they are same, equal vectors. We could just move it to this part. Then the final vectors u plus v will be from the tail to the last one's height. So this is u plus v. And from here we could redraw it. Here is a triangle. We could get A, B, C. This is 5, this is 8, and this angle. 30 degree is not in the triangle, so we have to bring it to this triangle. So here is Z pattern, is F pattern, so this one is 30 degrees. So this is F pattern because it's parallel, these two. So 30, 30, and this one will be 180 minus 30. So this is 30, then this is 150. So in this triangle, we have the side, and contained angle given. So SAS, from the sine law, cosine law, we know we don't have the opposite side, opposite angle given. So we are going to use cosine law in order to find this AC. This AC is the magnitude of our resultant, the sum of the two vectors. So we are going to label it using opposite angle. Opposite side will be small letter. So this opposite side is small letter A, this opposite side is small letter C, this opposite side is small letter B. We want to find the B, then the cosine law. The reason why we use cosine law because no, the sine law is opposite angle, opposite side. You have to have one ratio given. One ratio given means opposite side and opposite angle have to given. We have only one angle in this triangle, so B, opposite B not given, so we don't have one ratio given. We are not able to use this sine law, okay? So we need to have opposite angle and side given in order to use a sine law. Otherwise, we couldn't. We need one ratio given in order to set up an equation. So now we are going to use cosine law. We want to find the B. Then we have three forms of cosine law. In order to find the B, B need to be by itself. So we use B squared. The other two sides squared. A squared plus C squared minus double of other two side times. Then times cosine law, we have cosine angle. And this first and the last need to match. Angle B, side B, they need to match. They need to be same. Then we are going to just sub in the given information. So B squared equals A is 8, C is 5, minus 2 times 8 times 5 times cosine 150 degrees. Just get your calculator out and find the square root of whatever this one is 158.2820. So equals square root 158.2820, then B approximately 12.58. So this one is our magnitude. We also want to find the angle. So we just find one of the angle, then 180 minus this, we could find other angles. So we want to find the angle A. And this time, because we have this B 12.58, we have opposite angle B, side B given, so we could use a sine law. If you are able to use sine law, I highly encourage you to use a sine law because its calculation is a little bit easier than cosine law. So sine law, I copy that A over sine A equals B over sine B equals C over sine C. You could flip each of them, but if we use cross multiply, it doesn't matter. You use A over sine A or sine A over A. Now we sub in the given information. It's 8 over sine angle A equals B. We have 12.58. And here, try to keep more decimal places in the middle step. Over sine angle B is 150 degrees. That equals sine angle side C over sine angle C. And this time we want to find side A, this one, angle A. This ratio both given, we want to use this one. And this given, this is unknown. So in these two ratios, we have 3 given, 1 unknown. We want to use these two ratios to set up equation. And so continue here. 8 over sine angle A equals 12.58 over sine 150 degrees. You don't have to write this one if you know this is going to be used the first two. Then in order to find the sine A, we could do the cross multiply. Why we do it? Because we don't want to see the denominator. So we have 12.58 sine angle A equals 8 times sine 150 degrees. So, and in order to find the sine A, we want to move the 12.58 to other side. It will be division. And both sides divide by 12.58. Then the left side, we are going to have only sine A equals whatever the other side. Then we move the sine to other side. It will give you the just angle A equals sine inverse. When you solve for angle, we do the inverse of sine. Then 8 times sine 150 degrees divided by 12.58. Then get your calculator out. Angle A is approximately 18.54 degrees. Then we are going to write a statement. Therefore, the magnitude is 12.58, and the angle formed with U is 18.54 degrees. So that is the answer. We use sine law, cosine law to trigonometry to find the magnitude, the length of this side, and also the angle formed with one of the vectors. And now we want to use the algebraic vectors. Algebraic vectors means we are going to put it into the xy coordinates. So this is 0, this is x, this is y. Then for simplification, we are going to put the u on the x-axis. So this is 5. And v is 8. And this is 30 degrees. So the final one, what we are going to do is, we want to find the x component, y component. Then we are going to add the x component together, y component together. So this is y. So we are going to have ux, vx, and uy is 0, so we have vy. And the final vector x component will be just the ux plus vx. Ux is 5. Vx is 8. This is a right angle triangle, and adjacent equals, so this is a adjacent over hypotenuse equals cosine angle. So the adjacent will be hypotenuse times cosine. So this is a hypotenuse times cosine give us a x component. Then we do the calculation, we can find the x component. Then for the y component, it's uy plus vy. Uy is 0. Vy is opposite over hypotenuse equals sine. So opposite equals hypotenuse times sine. So 8 times sine, 30 degrees. Then use your calculator, you can find the x and the y component. So 5 plus 8 cosine 30 degrees. Make sure your calculator is in degree mode. It will give you 11.928. And 8 times sine 30 degrees give you 4. So the final vectors, you have x component, y component, then the magnitude is equals to the hypotenuse of this x squared plus y squared. 11.928 squared plus 4 squared, then square root. And you will find out it is equals to 12.58. That is what we got from the geometric vectors method. And the angle formed, so this is a x, this is y, so it's kind of you have the new vectors is this direction. Okay. So this is y value is 4, the x value is 11.92. So this angle, we have the opposite, we have the adjacent. The angle we could get is tangent inverse opposite over adjacent. Opposite is 4, adjacent is 11.928. Use your calculator, you should be able to find out it's 18.54 degrees. So this is another way that you could use to find the resultant vectors. You just find the x component, y component, add all the x components together. If you have more vectors, you could just continue add the third x component, fourth x component, all the y component add together, then the x squared, y squared add together, square root, find the magnitudes, find the hypotenuse. That is your magnitude for your resultant sum of your vectors. And the angle is just y over x. And inverse of tangent. Opposite or adjacent give you the tangent, then you do the inverse, then you have the answer. Compare these two, you will find out this algebraic vector method is a little bit easier. You just have step 1, step 2, step 3, step 4. And this one you need to use cosine law first, then sine law. So it has more calculation here. Here is pretty straightforward. So I don't mind which method you want to use as long as you know the final answer is right. 12.58 and the angle is correct, then it's great. So And after that, we are going to practice another example. Okay, so example 3, an airplane heading northwest. So if you see the directions, then we could use a compass. So we draw the compass here. North is up, south is down, left is west, right is east, northwest. From north turn 45 degrees, we call it northwest. So this is where the airplane is heading, the speed. And the velocity is this direction and a wind is 120 km per hour from 20 degrees north of east. So from east, then 25 degrees north of east, 25 degrees north of east. So east is our main direction, 25 is go the north direction. So this is 120 km per hour for the wind, and it asks you for the resultant ground velocity of the planes. That is our actual direction the airplane will go. So and we have known that if you use a geometric vector method, we need to use cosine law, and sine law is troublesome, so we want to just try the algebraic vector method. So we just use 1, 2, 3, 4 x direction, y direction, then the Pythagorean theorem, then angle. So 4 steps, and we are going to see this one we call the positive x direction, this is positive y direction. So x component we are going to have is and it's very important is we want to use the angle formed with x direction. The reason for that is once we have the angle formed with x direction, then the x direction is always times cosine angle because adjacent, and y direction is opposite, we use a sine angle. So it will be easier for us to do the calculation. So this is 45, then 90 degree minus 45, this formed with x direction is 45. So now we are going to see x component, this one is 500 times cosine 45 degrees. And we are going to put negative at front because it's second quadrant, the x is negative. Then plus first quadrant is positive, 120 times sine, cosine. So it's adjacent cosine 25. This is the x direction, then y direction is 500 is y is positive times sine 45. So this is opposite of this one. So opposite of hypotenuse is sine. Then this opposite is hypotenuse times sine. So if it's hard for you to see y, x is cosine, y is sine, we are going to draw this triangle here. So this is 120. Based on this angle, we could label it. This one is opposite. This is adjacent based on this 25 degrees. And this is hypotenuse. So we want to find this is our y direction, this is our x direction. We could use the SOHCAHTOA, the opposite over hypotenuse equals the sine. And the opposite is y. Hypotenuse is 120. So for y, we move the 120 to other side is 120 times sine. So that's where we got the sine. And for the adjacent over hypotenuse is adjacent is x, hypotenuse is 120, adjacent over hypotenuse is our cosine. Then we solve for x, we move the 120 to other side, so we have the x direction is 120 times cosine. So if we can write the angles always formed with x direction, then for x component, always adjacent is cosine. For y direction, is always sine. Okay, then we can use you can get your calculator and find the value for each. So after calculation, we find out the x direction is negative 244.796 is 80. Okay, and for the y direction will be y direction is 404.27. So do the same thing. The magnitude will be the hypotenuse of these two. So x squared plus y squared. Then we sub in, we find the magnitude, and for the angle, it's just the opposite over adjacent, y over x, then the inverse of tangent. So the magnitude, you add them together, square root is 472.61. And the tangent inverse of y over x. So if we just use the positive number, it will give us 58.80. And we know this is x direction, y direction is this one in the second quadrant. So this is our RA. This is 58.80. So use the xy to determine which quadrant it will be. Then we could write the direction. Okay, so the resultant the sum of the two velocity is 472.61 kilometer per hour. And the direction we could put it in the bracket. So it's from west to north. So west 58.80, then north. West, then 58.80, then north. So that is a final answer. So what we have done is x component, y component, then the hypotenuse of x squared, y squared, square root. Find the hypotenuse, then the angle is just opposite or adjacent. We find the related acute angle, and based on that angle, based on the xy in the second quadrant, which quadrant, to determine the direction. So in this lesson, what we have done is we have learned a new way to describe a quantity, not only one number but two numbers. One is magnitude, the size of that quantity, and another one is direction. And where we are going to use it is velocity, friction, forces, and other applications in real world. And we have done the equal vectors means same direction, same size. Opposite, different opposite direction, but same size. And parallel, it doesn't matter the direction, opposite or same. As long as they are parallel, we call them parallel. Then to add the two vectors, you need to put tail height, then tail height again. From the tail to the last height is your resultant addition vectors. Then we have done the two-way method to do the find the resultant vectors. One is geometric vectors. We don't use x, y. We just use trigonometry to solve the magnitude and the direction, or we could just use algebraic vectors. We introduce xy coordinate system. If there's no directions, we could just put one vector on the axis, then another one just based on the angle, draw it. Then we find the x component for both, add or subtract. Y component both add or subtract based on the direction. Then we have the x, we have the y, we find the hypotenuse, use x squared plus y squared, then square root. And in order to find the angle is opposite or adjacent, then do the inverse of tangent. Opposite adjacent is our tangent. Then that is all what we have done. So thanks for watching.